Namaste, I am Dr. Gaurav Singh from Department of Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya Sagar. And today we will discuss the type localities of Gondwana succession and morphology, distribution and significance of Gondwana flora. Now let us introduce it. It is the longest coal-bearing horizon of India, and after a long period of quiescence and sedimentation, the hiatus of almost whole of the Paleozoic, the intraplate stresses caused the development of rift valleys. Sedimentation started in the early Permian time. The sedimentation began with the deposition of basal glacial deposits, followed by fluvial succession and capped by volcanic traps during Mesozoic. Such a sequence of glacial, tillite, fluviatile, and volcanic traps occurred in almost all the continents of the Gondwana land. In Indian subcontinent, this succession is described as Gondwana succession, Gondwana system, or the Gondwana supergroup. Earlier, the events of sedimentation were considered to be of lower Carboniferous, but now early Permian time has been attributed to it. The Gondwana system essentially includes the continental sedimentation in rift valleys with a rare thin minor marine transgressive deposits during the early Permian. Along the northern margin of India, mainly marine beds were intercalated with the shallow marine depositional regime exposed in Kashmir belonging to Carboniferous Permian age. They are sometimes also induced under or included under the Gondwana sedimentation. Similarly, coastal marine deposits of Jurassic Cretaceous age along eastern and western margin of India sometimes contain plant-bearing horizons. They are also included in the Gondwana system. Nevertheless, mostly Gondwana system includes essentially the continental sediments deposited in the rift valleys of Indian peninsula of early Permian to Cretaceous age, mostly containing coal and plant fossils along with the terrestrial fauna. The sediments of Gondwana supergroup contain the characteristic Glossopteris flora and land fauna which are common to the land masses to all the continental or Gondwana land. The name Gondwana was used by Medlicott in 1872 but published by Feastmantle in 1876. The name is derived after the tribe and kingdom of Gond in certain central Indians, where the Medlicott studied the sequence for the first time. The Gondwana rocks are distributed in Godavari Valley, Narmada Son Valley, Damodar Valley and Obliterated Valley in Lesser Himalaya, mainly in the eastern part. A considerable part of the Gondwana succession is covered under the Deccan Traps. Gondwana sedimentation are also encountered below the Gangetic alluvium in the Bihar-Bengal region. The total composite thickness of the Gondwana rock is about 6 to 7 kilometers. However, in basin, they are only 1 to 2 kilometers thick. The Gondwana rocks occur in linear belts of narrow tracts with faulted boundaries, with some of the faults being sedimentary. However, a large part of the faulting took place post-depositionally, perhaps during the late Cretaceous times. They were essentially deposited in tectonically active subsiding rift valley system. The trends of the faults associated with the Gondwana succession usually follow the lineament of basement rocks. The faulting is usually asymmetrical, resulting in much up and down movements of the sediment fill. The lower Gondwana rocks are cut across by many intrusive dolerite dikes which are either of Raj Mahal age or early Cretaceous or of the Deccan Trap age, that is late Cretaceous. Lamprophire intrusive, that is microperidotites, occur commonly in the Damodar Valley and in Himalayan Gondwana rocks. These dikes usually occur north of Satpura ranges but are rare in Godavari and Mahanadi valleys. The emplacement of Lamprophire dikes was of high fluidity and high temperature. These dikes cause cooking of the coal up to 2 meters from their margins. Sometimes these dikes form a fine network of small dikes. The sedimentation of Gondwana is preceded by extensive glaciation and building of small ice sheets in central India. From this, ice and glaciers moved in different directions around main valleys. Some of these valley glaciers in India was also fed by the ice sheets present in the adjoining Antarctica flowing into Mahanadi and Godavari valleys. The regional paleoslope is generally towards north. The ice sheet moved into the Rajasthan from salt range from the North Indian to Kashmir and towards northeast direction. In the salt range, pebbles of Malani rhyolites are present from Rajasthan. Boulders of the Godavari Valley were derived from the Vindhyan rocks. The glacial sedimentation of the beginning of Gondwana deposition took place essentially into the rift valleys by braided river systems and lakes. With the warming of the climate, rivers started flowing at these valleys, depositing large amount of the sediments by fluvial processes. The general paleoslope was towards north, and most probably the outlet to the sea was towards northeast, part where a shallow sea existed having connection with the main Tethys. The climate during the early Permian time was cold and humid, which changed to warm in lower Permian time, which supported the vegetation. Early Permian sediments, namely Talchi and Mahadeva, show well developed cyclicity with repeated occurrences of the coal beds. By lower Permian time, the climate became more differentiated in different parts. In central India, climate became slightly dry with pronounced seasonal droughts that made coal difficult to get preserved. During early Triassic, when Panchayat sedimentations were laid down, the climate became warmer with long and dry spells. Mahadeva shows drier periods. For the Triassic, Gondwana sediments reveal hardly any coal seams, while during Cretaceous times, a new phase of sediments started with rather mild conditions, leading to the development of thin bands of coal seams. The Raniganj coal field exhibits one of the most important Gondwana successions, starting from Talchi to Mahadeva, stratigraphy of Gondwana rocks. Let us discuss the stratigraphy of Gondwana rocks. The Gondwana succession is mostly divided into two units, that is Lower Gondwana and Upper Gondwana. Now let us discuss each of the litho units pertaining to Gondwana. Coming to Talchi Formation, it is mostly characterized by the 10 to 50 meters thick boulder beds at the base, followed by 200-meter thick shales and sandstones. These successions consist of distinctive floral assemblages. In some places, Talchi sediments are interbedded with marine early Permian beds, namely Umaria and Manendragarh horizons. Coming to the Karharbari Formation, this is a succession of sandstone and shales with minor coal seams having fauna showing slightly cold climate. Then comes the Barakar Formation. Barakar is about 750 meters thick succession of sandstones with occasional conglomerates along with shales and coal seams having a carbonaceous material usually well preserved. Then is Raniganj Formation. This is about thousands of meters thick succession of sandstones and shales with prominent coal seams. In Satpura region, it is known as Bijori. Coming to Panchayat Formation, it is about 600 meters thick, consisting of the greenish brown sandstone and shales in the lower part and grey micaceous sandstones in the upper part, having remains of the Triassic reptiles. Then is Mahadeva Formation. This is mostly represented by Panchmari sediments dominated by sandstones but devoid of the coal seams. Next is Raj Mahal Formation. Raj Mahal succession is represented by carbonaceous and silicified shales interbedded with Raj Mahal traps. These are essentially intertrapian sediments having individual thickness from 1.5 to 6 meters. In Godavari Valley, Kota sediments are present which are partly considered equivalent to Mahadeva and partly to Raj Mahal. It shows sandstone clay units with a few limestone bands. They are known as Kota sediments, which has yielded fish and dinosaurian remains. Next is Jabalpur Formation. They are made up of the light colored clay and massive calcareous sandstones. Some of the shales are carbonaceous with thin coal seams. Now let us discuss the Gondwana succession in Lesser Himalayas. In Lesser Himalayan zone, mostly in the eastern and the northern sector, thin units of the coal-bearing Gondwana sediments are present. They occur in Nepal, Sikkim, Bhutan and Assam and are invariably interbedded with thin early Permian marine sediments. The flora of these rocks correspond to Talchi Barakar units, and linear trend of occurrences of these Gondwana sediments in Lesser Himalayan indicate that probably was an ancient rift zone in this part of the Indian shield which has been uplifted and deformed during the Himalayan orogeny. Then let us discuss the coastal Gondwana. in the region of the Kutch and Saurashtra in western India, and in several areas of the eastern coast, plant-bearing sedimentaries occurring, intercalated with the marine coastal sand facies. These successions have been traditionally described as the coastal Gondwana, although they are not a part of the inland Rift Valley systems. The important occurrences are Dhrangdhara sandstone, Himmatnagar sandstone, Umia sediments, and Barmer sandstones. On the east coast, important occurrences of the coastal Gondwana are the Athgad sandstone of Mahanadi basin, then you have Golapalli sandstone of the Krishna Godavari basin, then coming to the Raghavpuram shale of the Krishna Godavari basin, followed by the Tirupati sandstone of again the Krishna Godavari basin. Then comes the Budavada sandstone and Varmavaram shales, followed by the Pavalur sandstone and Satyaveda beds. Then you have Sri Perambalur sandstone and Shivganga beds. All these occurrences of plant beds of east coast appear to be the same age, that is early Cretaceous, and are interbedded with the coastal marine succession. It seems that these deposits are essentially coastal marine sedimentaries where plant material from land have been washed in and deposited in marine setting. Now let us talk about the climate, flora and fauna of the Gondwana supergroup. The paleogeographic reconstruction of the Permian time shows that except for the northern and the southern margin of India, where there were marine conditions, most of the India had extreme continental climatic conditions. During deposition of the Talchi sediments, that is early Permian, flora is similar in most parts of the Indian basin, but so far no land fauna has been recorded. During Barakar times, that is later part of the early Permian, climate became more warm and temperate, but the influence of the seasonality is not distinct. It appears that in Damodar and Raj Mahal region or basin, climate was moister than in Godavari basin. However, in lower Permian time, climate in central India became drier and less suitable for coal deposition. In northeastern part, climate was more favorable to deposition of coal. In Triassic time, there is a general warming in the climate and a pronounced seasonality. This may be related to the general global trend and changes in the climate circulation pattern. Condition of seasonal drought became more prominent during Jurassic Cretaceous time due to the separation of the India along the east coast, west coast, and from the continental masses, and the development of marine conditions along the margins of the India. The climate became rather mild. There was also distinctive changes observed in the life during the Gondwana times. The basal most flora in Talchi sediments is dominated by the Gangamopteris. The leaves were very small and fleshy and curved with fine and crowded venation. Near the top, the Talchi sediments, some more species of the Gangamopteris, almost 8, appear with the larger leaves and indicating some amelioration, that is the mildness of the climate. The leaves of the Talchi flora are without midribs, and this trend continued till the Karharbari. Few examples of the Glossopteris occurring in Talchi show small, narrow, mesh-like venation, whereas the pollen grains of the Talchi and Karharbari are monosaccate and seeds are winged. In the Barakar, however, plant genus Glossopteris dominates while Gangamopteris declines. Only one species of the Gangamopteris is present in Barakar. In these sediments, 12 species of the Glossopteris appear, and pollen grains become bisaccate. Then in Raniganj, 40 species of the Glossopteris are present. The Raniganj and Kamthi are two distinct locations in different parts of India. In Triassic time, Glossopteris flora disappeared and a new floral component, namely Dicroidium, appeared, which is a characteristic feature of the middle Gondwana. The Triassic sediments predominantly shows red-colored sediments with common land fauna and more drastic seasonal climatic variations. During Triassic time, aridity gradually increased, leading to the extinction of Glossopteris flora with very rare ferns. The Jurassic Cretaceous flora is dominated by new elements known as Stylophyllum. In earlier parts of this time, Psycherophytes and ferns are common, while in the later part, conifers and Gingophytes are common. During Jurassic Cretaceous time, the climate became more humid than Triassic time, with rather mild preservation of the floral elements. It was probably due to marine transgression along the newly formed coastlines of the Indian subcontinent. There is a general paucity of vertebrate fauna during the Permian time, probably due to cold climate, while in Triassic, well-developed vertebrate fauna, namely Lystrosaurus, was present due to warm climate. Other faunal elements were amphibians, large reptiles, freshwater fishes, and the asterids. The Jurassic rocks, that is Kota Formation, contained fossil fishes, asterids, pterosaurs, and dinosaurs with warm climate and seasonal droughts.